Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, Examples of Functions from Geometry. So there's a classwork at the beginning here, and it says Exploratory Challenge 1 through 4, and it says to, as you complete exercises 1 through 4, record the information in this table below. So we're going to skip this for now, and we're going to go to exercise 1, and here it is. And it says, use the figure below to answer parts A through F. It says, what is the length of one side of the smaller inner square? So I've already marked that as this red line here, and it is 6 inches. So there's number 1A. B says, what is the area of the smaller inner square? Well, area is 6. So area, let's write the formula and simplify, substitute, and solve. Area equals the sides squared. So area would equal 6. That's an S, not a 5. Area would equal 6 squared, so the area would equal 36 inches squared. Then it says, what is the length of one side of the larger outer square? Well, that is this here. So there's 1 inch. This piece here is 6 inches, and then another inch. So this is 6 plus 1, which is 8 inches. And it says, what is the area of the larger outer square? Well, the area of a square, again, write the formula. Area equals S squared. So the area equals 8 squared inches. So the area equals 64 inches squared. Use your answers in parts B and D to determine the area of 1 inch of the 1 inch white border of this figure. So we're going to take the area of the outside, subtract the area of the inside, and that is going to equal the area of the border. Okay, so let me just put that. Area of the border equals 64 inches squared minus 36 inches squared, and 64 minus 36 is 28 inches squared. F, explain your strategy to find the area of the white border. Okay, so before I do that, I'm going to go back, and now we have a 6 inch and an 8 inch. So we're going to fill in this table here. So exercise 1, side length of in inches, the inside square was 6, the outside was 8. 6 squared was 36, 8 squared was 64, and the expression to describe the area of the border was 64 minus 36. That is what we just did. Okay, so that's what we're doing in that table in the beginning. So 64 minus 36 will give us the answer. So what strategy did we use to find the white border? Okay, so what did we do? Find area of outside border and subtract area of inside border. Okay. So in other words, we took the 6 area, 6 times 6 squared, and then the 6 plus 2, which is 8 squared. So we're just adding 2 every time is what it will appear to be, because these corners here are going to be 1 by 1. Okay, so let's move on to the next problem, and this is just going to be repetition. Number 2. Okay, so what is the length of one side of the smaller inner square? Well, the length of this side is 9 inches. What is the area of the smaller inner square? Well, area equals S squared, so area equals 9 squared, so area equals 81 inches squared. The length of one side on the outer is the 1 plus the 9 plus the 1, which is 11 inches. Area of the larger outer is area equals side squared, so area equals 11 squared. Area equals 121 inches squared. Use your answer in part B and D to determine the area of the 1 inch white border of the figure. So I would say the area of the border equals 121 inches squared minus 81 inches squared, which equals 121 minus 81 is 40 inches squared. It says to explain your strategy for finding the area of the white border. Well, it's the same as before. You take the area of the outside minus the area of the inside. Now I'm going to express this well, no, maybe I won't go that far yet. So anyway, first of all, let's fill in that table that we did. Inside square is 9, outside square is 11. So we go to here. Inside was 9, outside was 11, 9 squared was 81, 11 squared is 121, and we take the bigger area and subtract the smaller area. Okay. Exercise 3. What length is one side of the smaller inner square? 13 inches. What length is the outside square? 13 plus 1 is 15 inches. Oh, no, we got to find the area first. Let's just move that down. I just answered the length of the larger outer square. Skipping steps here. So what is the area of the smaller inner square? Area equals S squared. Area equals 13 squared. So the area equals 169 inches squared. Okay, now moving along to this, what's the area of the larger outer square? Area equals S squared. Write the formula every time. It'll help you with substitution and memorizing the formulas. And 15 squared, and so therefore the area equals 225 inches squared. Use your answers in parts B and D to determine the area of the 1-inch white border. So the area of the border equals 225 square inches minus 169 square inches. And that is going to equal, well, 169, that's 31 away from 200, so 31 plus 25 is 56 inches squared. Explain your strategy for finding the area of the white border. I'm going to just say this from now on because it's the same every time. You take the area of the outside, subtract the area of the inside. Okay, so what were my numbers? 13 and 15. Okay, so going back to here, 13, 15, 169, 225, 225 minus 169. Okay, now we have number 4. It says write a function that would allow you to calculate the area of a 1-inch white border for any size square picture measured in inches. Any size square picture. So now they didn't give us a length. So if I'm going to call the side S, this is an S by S side. So this side here is going to be S, which is this piece, plus 1, plus 1. So that will be S plus 2. So what expression represents the side length of the smaller inner square? S inches squared. What expression expresses the area of the smaller inner square? S squared inches, or S inches squared. S squared inches squared, I suppose. And I made a mistake here. This is not inches squared. So what is the length of the smaller inner square? S inches. What is the area of the smaller inner square? S inches squared. C says to write an expression that represents the side lengths of the larger outer square. So that's the larger, that's this here, S plus 2. S plus 2 inches. Write an expression that represents the area. That would be the S plus 2 squared inches. So when I square that, I'd have to say inches squared. So use your expression in parts B and D to write a function for the area A of the 1-inch white border. So area A equals S plus 2 quantity squared minus S squared. So I'm going to go back to the front page now, and I will write side S, side length in inches, S plus 2. This would be S squared, and this is the quantity S plus 2 squared, and that would give me S plus 2 quantity squared minus S squared for any size square. Exercise 5 and 6. Okay, try these on your own. Pause the video, come back, and we'll check. So here we go. The volume of the prism shown below is 61.6 cubic inches. What is the height of the prism? So I highly recommend, and I highly stress this every time. Step 1, write the formula. Volume equals length times width times height. Volume is given. The volume of the prism below is 61.6 inches cubed equals the length L, 8 inches, times the width, 2.2 inches. That looks like 2 times 2. 2.2 inches times the height, h inches. Okay, so we have this. Now we need to multiply everything and combine like terms. So that is going to give me 61.6 inches cubed equals 8 times 2 is 16, carry the 1. 8 times 2 is 16, plus 1 is 17. And there's a decimal. So we have 17.6 inches times h inches squared, actually, because we're taking an inch times an inch, which is an inch squared. And this might get a little confusing here with all of our inches and stuff. Just keep in mind that length is degree 1 or power 1, and volume is power 3, and area is squared. So that is 117.6 inches is the area of the base. So that'd be squared, and then the height is length, and then that would give us a cube. But let's just not worry about the name in inches and so forth, and we'll just substitute that in at the end. So now we have 61.6 inches cubed equals 17.6 times h, which is the height. So to get h by itself, we divide by 17.6. And what you do to one side, you do to the other. These will cancel, and I'm left with h on the right equals, and so here's my calculator. 61.6 divided by 17.6 equals 3.5 inches. Okay, so just make sure you put that in at the end. So the height of this prism is 3.5 inches. Okay, number 6. Find the value of the ratio that compares the volume of the larger prism to that of the smaller prism. Okay, so we need to find the volumes of both. Volume equals length times width times height. I will do the larger one first. So the volume equals the length, 7, times the width, 9, times the height, 5. So the volume equals 9 times 7 is 63 times 5. 63 times 5, 630, half of 630. Should be 315, but I want to make sure. 7 times 9 times 5, 315. 315 centimeters cubed. Okay, so we have 315 cubic centimeters. Now we're going to do the same for here. Volume equals length times width times height. Volume equals length, 2, times width, 4.5, times height, 3. Why is that not erasing the last thing I did? Okay, so this is times 3. So volume equals 2 times 4.5 is 9. 9 times 3 is 27 centimeters cubed. So ratio of the larger prism to the smaller prism. So that is larger to smaller equals 315 to 27. Okay, so 315, I'm going to use my calculator here to speed things up. 315 divided by 27, enter, and then if I hit my math enter button, it'll reduce it for me, and that is 35 to 3 is the ratio of the volume of the cube, or the rectangular prisms. They are not cubes. Okay. Okay, so here is exploratory challenge 2, exercises 7 through 10. So we have 4 exercises we need to fill this table in, and it says no, base refers to the bottom of the prism. So the base would be the length times the width. So I'm going to write that. B equals L times W. So use the figure to the right to answer parts A through C. What is the area of the base? Well, the area of the base is length times width. So the area of the base is 12 times 3. This is my length. This is my width. So the area of the base is 36 centimeters squared. Area of base in square centimeters, B, 36 centimeters squared. Okay, let's just leave it with numbers for now, I guess, and that way we won't worry about the unit of measurement when we're multiplying, but actually we should do that. I'm going to leave that, centimeters squared. B, what is the height of the figure? 3 centimeters. That is right here. This is the height. What is the volume of the figure? Well, volume equals the base area times height. We already found the B, which is my L times W, so now I'm just going to substitute that in, which is 36 centimeters squared times the height, which is 3 centimeters. And we get the volume to equal 3 times 6 is 18, carry the 1, 3 times 3 is 9, plus 1 is 10. 108 cubic centimeters. So the height is 3 centimeters, and the volume was 108 centimeters cubed. So what we're doing is we're taking the B times the H to get the volume, and the B is length times width. So it's really length times width times height gives you volume. Okay, so let's move on. Use the figure to the right for parts A through C. What is the area of the base? Area of the base is length times width. So area equals length times width. Area equals 12 centimeters for the length times the width of 3 centimeters. So the area equals 36 centimeters squared. And the area of the base is B, so I'm going to start calling that B instead of A for area. So I'm going to write the B, or the base area, B. All right, what is the height of the figure? Here's the height right here, and that is 8 centimeters. So the volume of the figure equals the base area, length times width, times height. So the volume is 36 centimeters squared times the height, 8 centimeters. So the volume is 6 times 8 is 48, carry a 4. 8 times 3 is 24, plus that 4 is 28 centimeters cubed. Okay, so now I'm going to fill that in up here. So the B was 36 centimeters squared. The height was 8 centimeters, and the volume was 288 cubic centimeters. Okay. Exercise 9. Use the figure to the right to answers A through C. What's the area of the base? So B equals length times width, 12 times 3. So B equals 12 centimeters times 3 centimeters. So B equals 36 centimeters squared. 36 centimeters squared. What is the height of the figure? The height is right here, 15. So actually I should write H equals 15 centimeters. What is the volume of the figure? Volume equals the base area times the height. So volume equals 36 centimeters squared times 15 centimeters. So the volume equals 36 times 15 is 360 plus 180, which is 540 centimeters cubed. So we have 15 and 540. So this was 15 centimeters, and this is 540 centimeters cubed. Okay, and now number 10. Use the figure to the right to answer A through C. What's the area of the base? The area of the base equals length times width. Substitute length, 12 centimeters, times the width, 3 centimeters. So the base is 36 centimeters squared. 36 centimeters squared. What is the height of the figure? H equals right here, and it's x cm. Write and describe a function that will allow you to determine the volume of any rectangular prism that has a base of 36 square centimeters. So the volume equals the base area B times x for height. So since the base is 36, the volume would equal 36 times the height. So we have 36 centimeters squared, x centimeters, and this would be 36x centimeters cubed. Okay, there we have it. There's 1 through 10, or 6 through 10. 7 through 10. Okay, that is the end of lesson 9. Review this lesson summary and go do your problem set.